Hey you, stop being irrational. That means wild and ridiculous with no end and no pattern. Oh, I'm sorry, I didn't see you there. Let me do some math. Oh, rational or irrational? Oh, what's the difference between the two? Rational is like a regular old number that you can write as a fraction, like 5, or 5 over 7, or point something repeating, or a pattern, or whatever. Now, square root of 4. Oh, that's 2. Can I write 2 as a fraction? Well, certainly I can. 2 over 1. Is this rational or irrational? Rational, because 2 can be written as 2 over 1. What about 0.23232323? Well, I can write that as 0.23 repeating. And if you watch the very short video that I made about repeating decimals, I know that that can be written as 23 over 99, a good old fraction. That's rational too. The square root of 101. I don't know what the square root of 100 is. And what I do know is if I can't take the square root of a number nicely, it's always going to be irrational. So this guy is going to be irrational. .815 repeating. Oh, another repeating decimal. Well, if the repeating decimal over here is rational, then this repeating decimal over here is going to be rational as well. Rational, rational, irrational, rational. In between what two integers does the square root lie? Okay. In between what two integers does the square root lie? Well, I don't know what the square root of 14 is. I really don't. But I do know my perfect squares. 1, 4, 9, 16, 9, 16. I don't know what the square root of 14 is, but I do know that the square root of 9 is 3. And I do know that the square root of 16 is 4. Which leads me to think that the square root of 14 has got to be in between the square root of 9 and the square root of 16, which means my answer is going to be in between 3 and 4. That's it. Done. Done. In between what two integers does the square root lie? I don't know what the square root of 175 is, so let me think of my big square roots. 100, 144 is 12, 121 is 11, 144 is 12, 169 is 13, 196 is 14. Oh, you're going to live in between 169 and 196. 169 is 13, 196 is 14, so the square root of 175 is in between 13 and 14. Similarly, I don't know what the square root of 90 is, but I do know what the square root of 100 is, and I do know what the square root of 81 is, and I do know that the square root of 81 is 9, and the square root of 100 is 10, and 90 lives in between 81 and 100, which means square root of 90 is going to live in between 9 and 10. I do know that. Which is greater, the square root of 48 or the cube root of 127? Oh, let's find out. Let's split these in two. Square root of 48. I don't know what the square root of 48 is. But I do know that the square root of 36 is 6. And the square root of 49 is 7. So this guy is square root of 48, which is almost the square root of 49, which means this guy is almost 7. So I'm going to write that out because my job is to find out what's greater. I do have a calculator, but that's too easy. Cube root of 127. I don't know what the cube root of 127 is, but I do know my cubes are 1, 8, 27, 64, 125. Oh, okay. The cube root of 127 is going to be a little bit more than the cube root of 125. So this guy is going to be a little bit more than 5. This guy over here is almost 7, which is a whole lot more than a little bit more than 5. So which one's greater? This one is. Because the square root of 48 is 6 point something, and the cube root of 127 is 5 point something, and 6 point something is bigger than 5 point something. Interesting problem. So much fun. I can barely contain myself. Too bad I have to leave. Bye.